For our lesson today, we'll be using IC20. This is officially the first time that we are going to write proofs together. Our initial proofs are going to be in what's called flowchart format. This is going to help you to organize your brain so that you get used to what the idea of a proof is. And then once we're used to the idea where we understand how to fill in all of these boxes and blanks, we'll transition to what's called two-column proof format before you actually take your assessment over Standard 5. So we have two problems up here that are supposed to be review of our last couple of lessons in class 18 and in class 19. So the best thing for you to do right now is to go ahead and pause this video and work your way through these two examples. They are going to become the first two proofs that we do. So go ahead and pause the video, do your best to fill in these blanks for number 1 and for number 2, and then unpause to check to make sure that you've done it correctly. All right, welcome back. When we are looking at these two introduction problems, problem number 1 starts us off with 2 pairs of congruent sides. So on their own, that's not enough for us to match one of our 5 congruence criteria. Remember, those are SSS, SAS, HL, ASA, and AAS. Those are what we're choosing from. So we need some kind of additional pair of congruent parts if we're going to be able to say that these triangles are congruent. Thinking through all of those ideas that we talked about in class 19, I see a nice X where we have angles that are across from each other. So those can be marked using our vertical angles theorem, would have been that additional reason from our previous lesson, which means that now I have 2 pairs of sides and 1 pair of angles. So as long as I double check, I'm going to color code these with yellow and color code these with green. As long as I double check that that angle is included between the congruent sides, which it looks like it's where the yellow and green intersect in both triangles, then this will be a side angle side pair of congruent triangles. If we fill out our congruent statement, triangle VYZ names the triangle on the left side. So I need to name the triangle on the right side in a corresponding way. V is not marked as an angle, but it's at the end of that yellow double tick segment. So that should match with X. Y is at the end of that green single tick segment. So that will correspond to W. And then Z is the vertical angle where those 2 congruent sides come together. So it's going to correspond with itself. Hopefully that went well. For number 2, again, we have 1 pair of congruent sides and 1 pair of congruent angles. By itself, that's not enough, but I see right here a shared side between M and P that I can mark as being congruent to itself by the reflexive property. So now, again, I'm up to 2 pairs of sides and 1 pair of angles. If I color code this set of angles that has the double tick, it looks like the same thing happens as in my previous example. That angle is right where those 2 congruent sides intersect. So side angle side, again, is going to be the reason for why these triangles are congruent. Filling out our congruent statement, triangle LPM is the one on the left side of the picture. That's going to correspond to triangle NPM on the right side of the picture, if we match up all of those corresponding parts. So those 2 review problems are actually going to turn into our first 2 proofs. So we're going to continue to use the same thoughts. We're just going to be a little bit more formal about how we're writing it out and discussing what has happened in these diagrams. So what you'll see is that you have 2 pieces of information when there's a proof. You'll have facts that are given. Those are things that are true that we get to use to help us with the proof. And then we have what's called the proof statement, which is the ultimate goal. Givens and the proof statement are going to live in these boxes for our proof. And the reasons we know they're true are going to be in the blanks right underneath each box. So we know automatically that YZ as a segment is congruent to WZ as a segment because it was given to us. So the statement goes in the box, and the reason we know it was given to us, goes in the blank. And then at the same time, we want to make sure that we add that information onto the diagram. So YZ is congruent to WZ. Put some matching tick marks on there. That uses our first given. So let's move to our second one. ZV as a segment is congruent to ZX. That is also a given piece of information. And so we mark that on the picture. ZV is congruent to ZX. Now, another thing that's kind of good to do as you go is to mark whether these give you congruent sides, congruent angles, or not either of those things. So this was a pair of congruent sides. That doesn't have to be there for the proof to be right, but it's kind of helpful. This was a second pair of congruent sides. And so that kind of indicates to me that we're not quite ready to use one of our 3 or 5 triangle criteria because we don't have the 3 pieces that we need. So although these two combine together and they tell us a little bit about these 2 triangles, they don't tell us enough yet for them to be congruent triangles. So I'm on the lookout for my 3rd piece of information. Now up above, we said that the 3rd piece of information was these angles. So we can mark those angles again, like we did in our intro, and we can say that that's happening because of vertical angles theorem. That's the reason. But what makes the proof a little bit different than that intro problem is that we need to write it as a congruent statement as well. So we need to talk about angle something being congruent to angle something else. Think about whether we can just get away with calling them angle Z. I think hopefully that would be a bad decision since there would be 4 different angle Z's involved. So we need to go back to when we were talking about angles earlier in the year. Remember that we can name them with 3 letters and that vertex needs to be the middle letter. So this angle would be VZY, or we could have called it angle YZV. If we're naming the second angle, we might want to try to match up corresponding parts. So if I'm looking at VZ, that looks like it would match with XZ. And then to finish out that angle, we turn the corner and we make our way to W for a pair of angles. Now you'll notice that the way that these labels line up, they don't look like side angle side. So we're not looking at our proof to pick out which of our 5 triangle congruence criteria will work. We're looking at that diagram, which is why it's so important to put every statement's information on that picture. In the picture, just like in the opener, we can tell that side angle side is going to be the reason for why these triangles, triangle VYZ and triangle XWZ, are congruent to each other. That's your first proof. So we're putting all of the facts that we know are true in the boxes, and we're describing right underneath each box why we knew that fact was true. We're going to do that one more time here before we do a little bit more detail about the way that that proof is set up. So for our second one, in our intro problem, we had a set of angles that were already marked on the picture. If we're doing a proof, those angles won't be marked on the picture automatically, but we can go investigate their location and we can add that congruent mark on there to show where those angles live in the diagram. Again, that was one of my listed given pieces of information. So the reason I know it's true is because it was given to me. If we trace these letters in order, angle MPL is this one on the left side, and angle MPN is this angle on the right side. You can mark those with any kind of congruent arc or an arc with a tick or stars, whatever your preferred choice is for marking congruent angles. If we look at the next piece of information, that's more congruent parts. This time though, it's segment LP and segment NP. So that would be a pair of sides that we were given to use as our triangles, hopefully head towards being congruent. One pair of angles and one pair of sides is not enough information. So in the intro, we looked at that shared side and we marked that that shared side was congruent to itself. And so that is going to be segment MP congruent to segment MP. That's how we write that. That segment matches itself. So MP as a segment is congruent to MP as a segment, which gives us a second pair of sides. That was not given to us. That was us noticing the reflexive property. Just like over here, we use vertical angles theorem for an extra set of congruent angles. On this one, we're using reflexive property for an extra set of congruent sides. So again, we're not looking at the order of the letters in the proof because angle side side is not even an option. We're looking at the way they show up in the actual diagram. That looks like side, angle, side again. So that would be the reason our proof statement is true. Triangle LPM is congruent to triangle NPM. All right, your first two proofs are done. Go ahead and flip the page over and we'll talk about a few more details to wrap up our notes for today. On the back, we're just going to talk about some details that kind of explain this process a little bit more. So we're not doing another proof. We're just talking about these pieces and making sure you understand what all of them mean, what they come from, what they might look like, okay? So more about proof in general. Mathematicians are expected to justify their work, and one process for this justification is called proof. So proof is just a way of explaining why things are true. There are many different ways you can write proofs, different formats. Our specific geometry class focuses on these flowchart proofs that you've started to see. And then, as I mentioned, we're going to transition by the time you take your assessment into 2-column proofs. But there are also paragraph proofs and all kinds of other ideas or ways of writing them out there in the world. So what our goal is to support a geometric idea with a complete, organized, logical explanation, which means the information needs to be in a certain place, in a certain way, with a particular order. So you might feel like there's a lot of details, and you're right, there is, but the goal is that we have an airtight argument for why something is true. Okay? So the parts of the proof, we've already talked about a few of them. We have what are called given statements. That's information we are given, which seems a little silly. So if you want to explain that to yourself, it's stuff that we are told is true. Okay. Then we have the prove statement. That's going to be the goal of the proof. So that's going to be where we make it to at the end of all of the reasons, statements, argument, all of that. Okay. Then we have some other things available to us, okay? Some different pieces. We have what are called statements. Statements are information that is true, but it also needs to be helpful. So we can't just go filling in these statement boxes with random facts, like, I don't know, water is H2O. That's not helpful for our proof. So we only want to write things down that are true, but also helpful as we're working through the process of making it to this goal, this proof statement. And then along with those statements, we have what are called reasons. And those are the justification for why or how each statement is true. So far we've seen 4 reasons, maybe 5 on our first 2 proofs. We had given, vertical angles theorem, reflexive property, and then our 5 triangle criteria, side, 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 side angle, side. The 2 proofs that we did were side angle, side proofs. Those have been our reasons so far. Okay? So over here is just a blank flowchart proof, and you'll notice that this one is a little bit different than the one that we had. Well, for two reasons. It's got a bunch of type over the top of it explaining what these different sections are about. But for a second reason, our proof started here with these three rectangles and continued down to our proof statement rectangle. You'll notice that this proof has a series of bubbles up top, and then it's got the three rectangles, and then it's got the proof statement rectangle. That's because some proofs are more complicated than the ones that we just did, but we're starting basic. So we're just focused on proofs today that are from here below, but when we move to the more difficult proofs, you'll need some space up top in the bubbles. And so we're going to try to get a good idea of what would be in a bubble versus what would be in a box versus what would be at the bottom in that final box. So up here in these bubbles, you're going to write down givens if they require some extra or additional or new knowledge to be useful. So whatever you want to write in there. So that would be things about, let's say, midpoints or angle bisectors. So like if somebody told you that something was a midpoint of a segment, that would go here because then you would have to describe what was true because of that directly below it. So those are things that need to be processed a little bit, okay, in order for them to actually have congruent symbols is a good way to think about it. So right underneath here would be reasons. Okay, so these blanks are for the reasons that explain how you know what's right above. So that could be given, or it could be definition of midpoint, or it could be vertical angles theorem. There's lots of options for your reasons. The same information would be true about this set of blanks that are reasons and this reason at the end, okay? So then this middle section, these ones that we saw in our proof today, could be givens, and that would be the case if they don't require extra information, extra knowledge to be useful. So in this first standard of proofs, that means that they're going to be statements either about congruent sides and or angles. Okay? The only exception to that is that sometimes we'll have a statement in this lineup about right angles if it's an HL proof, but almost always these are going to have statements about congruent sides and or congruent angles. And then this one at the bottom, that's the conclusion. So that's where your proof statement will always go because you've made it to your goal. All of these ideas combine together, they funnel down, and they create this new geometric fact that you were trying to prove. So for us, this is almost always about congruent triangles. So maybe triangle ABC is congruent to triangle DEF, and then your final reason will be side, 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 or side, angle, side, or HL, or angle, side, angle, or angle, angle, side. All right, that's your first introduction to proofs. Thanks for watching.